Hello, I am Dr. Sigarkanti. In this video, we write Python program for weddles rule. Weddles rule is if y equal to f of x, then integration of y dx from x0 to xn is given by 3h by 10 into y0 plus yn plus 2 times y6 plus y12 plus y18 plus up to yn minus 6. That is, suffices are divisible by 6 plus 6 times y3 plus y9 plus y15 plus up to yn minus 3. That is, suffices are divisible by 3. Okay. And divisible by 6 are here. So we are considering y3. We are not considering y6 here. y6 here. If y6 is there, then its coefficient becomes 2 into 3h by 10. If it is suffix is 3, 9, 15, okay, these are all divisible by 3, then the coefficient is given by 6 into 3h by 10 into y3 into y9 into y15 like this. And if the suffices are even 2, 4, 8, then that is except which are divisible by 6 here. We are considering the suffices, even suffices here, except the 6, 80, 6, 12, 18, and so on. Then its coefficient is 1 into 3h by 10. Else, otherwise, that is, if it is not divisible, the suffix is not divisible by 2, not divisible by 3, not divisible by 6, then its coefficient is 5 into 3h by 10. That is y1 plus y5 and then y7 or y11. So these are the terms here. So this is our Weddell's rule formula. Here h is equal to the width of the subinterval xn minus x0 divided by n. And here we have to divide the interval into multiple of 6. So that is here. The interval x0 xn is divided into n equal parts. Width is equal to h here, and here we have to take n is a multiple of 6. So x take the values x0, x1, x2, x3 up to xn. That is, x1 means x0 plus h, x2 means x0 plus 2h, x3 is x0 plus 3h, and xn is x0 plus nh. And the corresponding values of y are y0. Y0 means f of x0. y1 is f of x1, that is f of x0 plus h. y2 f of x2, that is f of x0 plus 2h. y3 is f of x3, that is f of x0 plus 3h. yn is f of xn, this is equal to f of x0 plus n into h. Then how to write the program here? So this is the example here. We have to evaluate 0 to 1, 1 by 1 plus x square dx by Weddell's rule. For writing this program, first we have to define the function y equal to f of x. That f of x is 1 by 1 plus x square. Then after that we have to give the input. That is, we have to input x0, we have to input xn, we have to input n. After this input, we have to find out the value of h. Then our process start here. We define one variable. Let me denote that variable name by SW, and I will initialize this to 0. And then I will consider a for loop here. That is, for I in range n plus 1. That is, I take the value from 0 to n. And every time I am going to update the value of this SW. Suppose the suffix is 0 or n, then what is the coefficient here? 3h by 10. So here, first I will go for this. If I equal to 0 or I equal to n, then SW equal to SW plus 3h by 10 into f of x0 plus ih. That is f of x0 or f of xn. If I equal to n, f of xn. I equal to 0, this is f of x0. If not, I is not equal to 0, I is not equal to n. Next, I will check whether is this divisible by 6. That if the suffix is multiple of 6, then if suffix is multiple of 6, so this is the case here. Then here, what is the coefficient here? Coefficient is 2 into 3h by 10. If the suffix is divisible by 6, then coefficient is 2 into 3h by 10. That is, if suffix is divisible by 6, then coefficient is 2 into 3h by 10 into f of xi, that is f of x naught plus I into h. If not, if it is not divisible by 6, then I will check whether is it divisible by 3. Yes. If it is divisible by 3, that is 3, 9, 15, n minus 3. Then what is the coefficient here? 6 into 3h by 10. If it is divisible by 3, then SW equal to SW plus 6 into 3h by 10 into f of xi. That is f of x naught plus ih. If not, if this even, if the suffix is even, that is 2, 4, 8 up to n minus 4, then its coefficient is 1 into 3h by 10, that is 3h by 10. Coefficient is 3h by 10. That is coefficient is 3h by 10 into f of x naught plus ih. SW equal to SW plus 3h by 10 into f of x naught plus ih. Else, if this is not the case, then this is the case. That is, this is the case here, y1, y5, yn minus 1. Then the coefficient is 5 into 3h by 10. Coefficient is 5 into 3h by 10. That is, else SW equal to SW plus 5 into 3h by 10 into f of x naught plus I into h. So that is, I take the value 0, SW is updated, I equal to 1, I equal to 2, I equal to 3, I equal to 4, up to I equal to n. Every time the value of SW is updated here. That is, every time we are going to add the terms here. First term, second term, third term, fourth term, fifth term to that n plus 1 term. Okay. Then after finding the after completing this for loop, then SW will have the value of that integral. Then I will come out of this for loop. Then I will print the value. The value of the integral is around SW comma 4. So that this rounds up to 4 digits after the decimal point. Okay. Let me run this program. Weddles rule. Yes, this is the program. I have written the comment line. I have defined the function. I take 1 by 1 plus x square. I am entering the lower limit. I am entering the upper limit. I am entering the number of subdivisions. I am finding the value of h. And I am defining the variable SW, initialized as it is equal to 0. Then I am using the for loop here. If I equal to 0 or I equal to n, SW equal to SW plus 3h by 10 into f of x naught plus ih. If not, next again, else if I percent 6 equal to 0. That means if the suffix is divisible by 6, then SW equal to SW plus 2 into 3h by 10 into f of x naught plus I into h. Else if not, if it is not equal to 0, not equal to n, and it is suffix is not divisible by 6, then if the suffix is divisible by 3, then SW equal to SW plus 6 into 3h by 10 into f of x naught plus ih. If not, else. Is this even? If the suffix is even, then SW is given by SW plus 3h by 10 into f of x naught plus I into h. Else, the last case, SW equal to SW plus 5 into 3h by 10 into f of x naught plus ih. After this completing this for loop, I will come out of the for loop here and then I will print the value of the integral. Okay. Let me run this program. Running this program. Enter the lower limit 0. Enter the upper limit 1. Enter the subdivision. So if I enter 6 here, then this is the value. Again, once again, if I run this program, lower limit again I will put 0, upper limit again I will put 1. The number of subdivisions I will put this as 12, which is divisible by 6, 7.7854. Once again, if I run this program, enter the lower limit 0, upper limit is 1, subdivision I will enter as 18, which is divisible by 6, 0.7854. Okay, this is how we can write the program for weddles rule. And the function is changed. Suppose the function is x by 1 plus x square, then just have to change here. If the limits are same, then just we have to change the function. Again, if I run this program, lower limit is 0, upper limit is 1, and number of subdivisions say 12, 0.3466. Once again, if I run this program with n with different n, lower limit 0, upper limit 1, and I will take say 24, number of subdivisions 24, 0.3466. Okay. Now I will consider one more function here, that is integration of 1 by 1 plus x with the same limits. Running this program, lower limit, enter the lower limit 0, enter the upper limit 1, enter the subdivision 6, 0.6931. Once again, if I run this program with different value of n, lower limit 0, upper limit is 1, and I will enter n is equal to say 12 here, 0.6931. Once again, if I run this program with different value of n, lower limit 0, upper limit is 1, and I will take number of subdivisions are say 24, which is divisible by 6, 0.6931. Thank you. I will stop here.